How to review chemical bonding. In this video, I will summarize how I review the absolute key concept in my science classes, which is chemical bonding. Considering Valentine's Day is just around the corner, we can certainly relate to the innate desire of atoms to pair up with each other. And at the core of these atomic relationships is the so-called Coulomb force, which states that opposite electric charges attract and likes repel. Considering this is a review, this means I will start off with a collection of key notes that I've captured with my students in class using Google Keep. As a digital system, hopefully as a result of highly engaging interactive labs and mini lessons. See the above link for my explanation on how to implement this note-taking tool into your high school classrooms, if your school supports the Google Workspace for Education. After all this digital note-taking, it almost feels like a breath of fresh air to transfer and distill these notes onto paper. How organic, wouldn't you say? So follow me along as I will show you how to turn basic printing paper, like this, into a bonding foldable. And for those of you that are in a hurry, possibly because a strong Coulomb force is pulling you elsewhere, check out all my bonding review sources linked in the description below. So we're going to start off with basic printing paper. You're going to fold that paper sort of in half by not really tightly folding it, but just giving it a little crease in the middle. That allows you to fold the bottom half towards that crease in the middle, and you do the same thing with the top half. So let's get rid of that one. This piece of paper has now been folded the bottom half. You're going to do the same thing on the top half, so that you will have a piece of paper that has two flaps, one at the bottom, one at the top. Next step is to basically fold this together in the middle. That is going to look like this, right? And then your final step is very simple. Take some scissors and cut it exactly in the top crease up here and the bottom crease down there. And it should look like exactly this, with 1, 2, 3, 4 flaps. What are you going to do with these 4 flaps? Well, that's so powerful about the bonding. There are 4 concepts. Metallic bonds at the left top, ionic bonds at the right top. Intermolecular forces can go on the right bottom, covalent bonds at the left bottom, and that's your starting point. So we just went from extensive bonding notes in Google Keep to the big idea notes and drawings transferred onto an organic foldable, like the one pictured and the one in my hand. Sometimes during this process of distilling notes, new questions arise, which may require some additional reteaching, perhaps with the implementation of another simulation, to help drive home the concept of, say, intermolecular forces, whether it be the strong hydrogen bonds or the weaker van der Waals forces. These interactions lay at the heart of physical states of matter, again driven by Coulomb forces. So as a result of an earlier YouTube video that I created, which I released on periodic table trends using the CODAP web tool, see the above link, I came across this really neat Concord Consortium Simulation that enables students to compare between the varying strengths of intermolecular forces, depending on the polarity of the interacting molecules. So I really want to show you this Concord site. So you basically go to the link highlighted above. I'm going to escape from my Google Slides and travel to that actual Concord Consortium. I've typed the keywords comparing attractive and hit go. And as a result, 3 activities came up. Now, you can do the whole login and assign these 3 activities to your class, but I always am cognizant of all the different places you can send your students to online that may require a login. So you can actually do these 3 activities just by hitting preview, and it allows your students to do them all. So I've picked a couple of these. So let's go to the first tab. And again, I just click on them, click review, but to avoid the whole loading, I go straight into the first one. And they're going to explore different attractive forces between polar and nonpolar molecules. So we're going to select a pair of molecules and drag the star image found in their simulations. So we're going to start by pulling apart 2 nonpolar molecules. And so the star, very much green, very applicable to the current Christmas theme, and you can see how easy it is to pull these 2 molecules, nonpolar molecules, apart. So let's make it a little bit harder, or maybe a little bit more hard, by picking 2 polar molecules. Similar idea, obviously these 2 molecules are polar, as indicated by the opposing charges, and by clicking on that same star, it takes a lot more force to pull them apart. So the intermolecular forces are a lot stronger. It seems like a really, really simple simulation. But let me tell you, I just watched my students do it the other week, and it really helped drive home this concept. So let me show you one more. So we're going to go to yet another activity, very similar. Instead of these being more anonymous molecules, we're now looking at specific molecules like hydrogen and hydrogen. Same idea, 2 nonpolars, very easy to split apart. And I'll choose now 1 nonpolar and 1 polar molecule. And again, a little bit harder to break them apart. Okay? So back to our actual slideshow where we left off. So that basically allows students to take some notes down on the polarity nature of the molecules at play and how easy or not easy it is to pull them apart, which is an indication of how strong or weak the intermolecular forces are. Okay, that brings us to the following. So we have now initially captured and organized notes in Google Keep, shown at the top left. Then we've distilled these notes on an organic foldable, followed by a re-explained session with the help of the Concord Consortium. Let's check and see if our students are now ready to put their bonding knowledge to the test. So that step I do through a program called Castle Learning. And what you're seeing on this screen here is basically a capture of questions that I've selected through Castle Learning. And I'll take a look here and show you how I've done that. So this is the actual Castle Learning site, and we do have a paid subscription to this, and I've used this site to basically select 10 free response questions, all related to bonding, that I've then placed into a Google Doc. So again, you might think, why not let students sign into to Castle Learning and do the assignment right in there? But that would mean yet another login, so it's a little bit more work on my part, and instead I'm letting them complete this so-called review on bonding, these 10 free response questions, by simply uploading a Google Doc in Google Classroom, and this way they can answer the questions right here without another login. Okay, so that brings me to actually testing through a summative, not a formative, but a summative assessment to see whether they actually grasped the whole bonding concept as a result of me teaching, doing mini lessons, doing interactive labs, but then also reviewing with them through the different activities that I just described. And that final summative assessment is an actual, let me go to the questions, a 10 multiple choice question quiz on bonding. The quiz, which I've created in Google Form, are based on the exact same 10 review questions. The key difference about these questions, however, is that even though they are the same questions, these questions I turned into a multiple choice set. So I had to now type in the various multiple choices, but it facilitates for me the grading, and it gives students the exposure to the free response, and then they can test whether they actually understood it by completing this Google form in a locked down browser, and that would be the summative assessment. Okay. Now, I'm very much aware that this may not be the most streamlined method because I could have done all this in Castle Learning. So Castle Learning does allow you to do a Chrome browser lockdown. So if I were to choose to do a student login and uploading the question bank and the actual summative test right in Castle Learning, I could have avoided some steps. But I'm thinking this through. Stay tuned. So back to the eventual overall bonding review. It basically concludes it here. All resources can be found in the description below. Thank you for watching. Thank you for subscribing. Bedankt voor het kijken en tot ziens.